Let me show you the transformation steps, how we convert the software applications into machine language program. Whatever the applications we create using high-level languages like C or C++, it will be compiled into assembly language program, and then the assembler is going to convert the assembly language into machine language. Everything is going to be in binary, and the processor is going to execute only machine language program. Look at this example. This is how we define expression in high-level language. Could be system Verilog or C or C++. There is an expression, and the compiler, RISC-V compiler, converts this expression into assembly language. So these are all RISC-V instructions: add I, shift left logical, and I. This is how the assembly program would look like, and then the assembler is going to convert this assembly language into machine language. To convert this into machine language, it follows RISC-V ISA. RISC-V ISA defines the format of the instruction. There could be different formats like R, I, S, B, U, J. So here if you look at add I falls under I type instruction, immediate type. SLL, shift left logical, falls under R type instruction. Again, AND I falls under I type. So based on the format, it's going to convert the instruction into binary. For example, look at here, I type, there are 12 bits for immediate values. So this 2 will be stored as 12 bits in the memory. That's what ISA defines. And then there are other fields like destination register and source register, and for each register it takes 5 bits because there are overall 32 registered, so we need 5 bits to address each register. So finally it would look like this. As I mentioned here, look at this 2 will be like 12 bits, so all zeros and 1 0, which is nothing but 2, right? And there is opcode, and then remaining things could be like function. So here 0 0 0 indicates its add function, and it also indicates the source register and destination register. So this is 12, this is 28. So this is x12, this is x28, and this is the function, which is nothing but add, and this is immediate value 12 bits. So overall if you consider 32 bits. This is defined by RISC-V ISA, and this is how the instructions will be converted into binary. So finally the binaries will be loaded into RAM, and then the processor is going to fetch the instructions one by one. So everything is going to be executed in terms of binary.